Welcome everyone to Manufacturing Talk Radio. My name's Tim Grady. I'm here with my co-host Lou Wise.
Good morning.
We are at FABTECH 2015 in Chicago at the McCormick Place Convention Center, where we have 750,000 square feet of exhibit space. And we have one of the exhibitors here with us, Tom McGaughy. And by the way, we have a contest, a guest at mfttalkradio.com. The first person who can send us an email and spell Tom's name correctly can win a free copy of Steel Forge, Steel Weights, or get one of our coffee mugs. Tom McGaughy with EWI, Director of Technology. Tom, thanks for joining us for the show.
Thank you. Well, thank you for having me here. It's an honor to be here.
Thank you.
Give us a feel for what EWI does.
Okay. EWI is located in Columbus, Ohio. We are the largest engineering and R&D organization in North America, focused on materials joining and forming technologies and other allied manufacturing technologies. We're located in Columbus because we're closely allied with the Ohio State University and their welding engineering program, in part. That's one of the reasons why we're there. Our job basically is working with industry. We work across all sectors of the industry, from automotive to aerospace, shipbuilding, defense, all the way down through to consumer products. Our clientele range from very small companies to the very large Fortune 500 manufacturers. And what we do for them is solve day-to-day technical problems. Maybe it's a welding line issue that needs to be solved, or a productivity issue, all the way to helping to develop new technology, next generation technology in the materials joining and allied technologies, and deploy that to industry. So our job is solving industry problems, making manufacturers more efficient, more cost productive, so they can compete globally.
What kind of interesting challenges are you solving?
It runs the full gamut.
I bet it does.
If we look at the list of challenges that manufacturers face, I don't think there's anything new today that we didn't see 10 years or 15 years ago, but I think maybe the level of intensity of some of these challenges has risen. So I see us right now, here in 2015, being in sort of a manufacturing revolution that encompasses several elements. A lot of this is being driven by, of course, global competition.
Right.
I think some of it is a natural consequence of coming out of the Great Recession and some of the structural changes in the economy that produces. But some of the things we see, for example, part of this revolution involves significant materials challenges. So we see now a number of industries either adopting new materials that just a few years ago were not available sort of on a mass production basis, or maybe they're adopting materials that are what we consider to be mature materials, but they're being used for new applications and in new ways that are creating some very significant challenges. So a very simple example that most people recognize would be the automotive industry. Traditionally heavy users of steel, stainless steel. Today, because of lightweighting demands, we're seeing a rapid increase in other lightweight materials, from aluminums to magnesium and titanium. And this is creating rather significant challenges, as you might expect, in terms of materials joining. So how do you weld or join these materials? In some cases, the existing technology just simply doesn't work. So you have to go back to old technology. So in some cases, we're using riveting and glue again to join materials, simply because the aluminum that's being used isn't particularly welder-friendly grade of aluminum. So there's some very significant challenges there. In some cases, we have just new materials that didn't exist a few years ago. Some of the ultra-high-strength steels, or some of the advanced ceramics and so forth. So there's some very significant challenges there. And in fact, industry's got to move in this direction. If we can't solve these challenges, the existing companies that produce these parts risk either a declining market share or potentially even going out of business.
In the 50 years that I've been in the metals producing and distribution business, at one time materials like Inconel, and at the time it was pronounced mono, and they finally got it that it was monel. Today, you can get almost any service center and buy it off the shelf.
Exactly.
In those days, you had to buy 10,000 pound heat of material, and then they didn't know what to do with it because they didn't really have the equipment, the experience, the talent, the skills, and so on. So even the materials, as you pointed out, have radically changed.
Yeah, materials have changed. I think another area is just product performance. We're seeing, and this is nothing new, there's always an increasing demand from consumers and end users to get more out of their product. But let's take batteries, for example. Battery technology is very much a critical technology in advanced energy, obviously in the automotive area as well. But the demands today for battery technology is we need batteries that have more power, just can deliver more power faster.
Right.
And this also is leading to very significant materials and joining challenges, because typically the weak link in a lot of cases is the battery terminals. It's where you're actually taking the power out of the battery to wherever it's got to be used. And there's a metallic connection there, aluminum or copper, what have you. And that tends to be the weak link in terms of performance, where you have failure in these connections. So product performance is one. So you see that in batteries. So obviously in automotives, we see this with the new CAFE standards that are coming online. There's going to have to be substantial improvement or increase in the mileage efficiency of vehicles. Mm-hmm. We see it across the board. The aircraft, more fuel efficient aircraft, all that sort of thing. So these create a number of technical challenges, not just in the materials or joining area, but even just sort of material process, even through your supply chain.
Right. Before the show, we were talking about a national roadmap for materials joining and forming technology. Explain to our listeners what that is.
Yes. So EWI has been engaged for about a year and a half now. It's a 2-year effort funded by NIST, the National Institute for Standards and Technology. This is a program designed to canvass industry, academia, and government entities to identify key gaps and needs in materials joining and forming areas. So our roadmap is focused on materials joining and forming. And in materials joining, we're talking about conventional welding that most people recognize, arc welding, solid-state welding, but also covers adhesives and brazing and soldering and so forth. And then also all the forming technology, so metal stamping, deep drawing, forging, and so forth. The intent here is to go out and canvass industry at large. This is focused on U.S. industry now, to identify key gaps and needs that are impeding the global competitiveness of U.S. manufacturers.
Okay.
And with that information, put together a roadmap, identify what the key challenges, key priorities should be that we need to address. Also sort of identify the economic payback. The end result here is not just to do sort of sexy research, but is to develop technology that ultimately can be deployed on the manufacturing floor and make a real positive impact for manufacturers. So we're looking at things in terms of the path of implementation, looking at gaps and needs and how do we deploy this to industry. The ultimate goal is to improve and strengthen the manufacturing base here in the U.S.
So this is where Department of Commerce, NIST, is actually participating
Yes.
and helping this project.
Exactly. So they're leading this. NIST is leading this effort through Department of Commerce funding. This is a stage 1 project where we're just involved in developing the roadmap. In that process, we'll be pulling together research partners that we feel are necessary to go and execute the roadmap. So the idea is to have a series of projects that will be funded under a stage 2 funding level, we hope,
Right.
sometime next year beginning. That may take us 5 to 7 or 8 years or so to execute, to bring new technology or advancements to the manufacturing floor that will improve our manufacturing base here.
One of the challenges that manufacturers have to be running into, because Lou and I have heard it on many shows that we've done, is workforce development.
Yes.
What are you folks doing in that area?
Interesting. Actually, as we started this roadmap effort with NIST, we were not planning to include workforce development as part of our roadmap topic. And NIST actually made that a requirement. I think it would have come out regardless, but it's fortunate, I think they asked us to really address that. Workforce development has turned out, certainly over the last couple of years, has become probably the singular issue in terms of manufacturers being able to get to the next level. We've heard that for many, many years. 20 years ago at EWI, we heard that in terms of the need to get access to good technical talent. I think it's risen to certainly in some companies maybe near crisis level, but certainly across the manufacturing landscape, it's become the singular issue. And it runs the full gamut from having access to degreed engineers and scientists to work at the higher levels, as well as skilled trades and technicians and machine operators. And I think there's a number of issues. One is the fact that we had many companies in our road mapping effort. As we went out and canvassed industry, we had a significant number of companies that indicated that about 50% or more of their technical workforce is age 50 or older. So they're in late stage or nearing late stage career.
Right.
There's an insufficient number of folks sort of at mid-career that are ready to step in and take their place, but they have some younger folks. One of the challenges is just transferring that knowledge from your more senior workforce to your younger workforce. There's cultural issues, communication differences, and just structural issues within companies that can minimize that. But that's clearly one issue, is that you have an aging sort of technical workforce.
We actually heard one company who, in the attempt to have transfer of information, where they were paying the older workers an incentive to work with like a commission to work with the younger ones, and so that they could put up with them, they give them more money. And that seems to be working for them.
That's an innovative way to approach it, and I think companies will have to look at things like that. Oftentimes I think that knowledge transfer just isn't always going to occur during the normal workday. There's so much you can learn on the job, of course, but I think it would require some extra effort. So I think looking at new ways of engaging the workforce and incentivizing them to make this knowledge transfer happen, I think will be important.
But one thing you need is to have more of your younger generation look at manufacturing as a real plus, not only financially, but reward-wise.
Yeah, that actually was probably the second element in the workforce development issues that we uncovered, was just a declining number of young folks entering the workforce for manufacturing careers. And part of it, I think, is a cultural issue here within the U.S., right? I mean, there's still this connotation on the street that manufacturing suffers from the 4 Ds, right? Dark, dirty, dangerous, and declining. And in fact, that's just not the case anymore. Manufacturing now is a very advanced technology, moving very quickly into the digital realm. But jobs that we think of in the past, machine operators and so forth, that didn't require a lot of specialized education, that's just not the case anymore. Today, in many cases, you need a college education, at least some sort of specialized vocational education, to learn how to operate these machines. They tend to be computer controlled and so forth. But that is a huge gap in terms of just filling the ranks.
Sure.
And I think it's leading to some new, pushes to go into automation and things like that, which is an issue I think that will be a challenge for industry as well.
Yeah. One of the other obstacles is the robotics, which is coming on very strong, but you need people to make the robots.
Yeah. It's interesting. We even delved into that quite a bit in part of our road mapping efforts, and there is a rapid increase in use of robotics and other forms of automation in manufacturing. Surprisingly, and I think it's good, what we found is that it hasn't really displaced as many jobs as some folks might think. Right. Certainly the manual jobs, labor-intensive jobs are being displaced, but actually for every robot or automated system in place, you actually need a team of people that have to design that, develop the software algorithms for that, monitor, repair it, and so forth. So it leads to really a whole new realm of technical workforce to support this automation robotics. And I think that's a positive outcome.
Yes, their argument would go that as we become more advanced, you need fewer workers, but the reality is the population of the United States continues to grow. People being employed continues to grow. 5% unemployment today is a bigger number than 5% unemployment 50 years ago. So we get more advanced, we get more workers.
I think the perfect example of that ideology is that when computers started coming on stream, everyone said that we're going to become the paperless society. And that's one of the greatest lies ever told.
Right.
Tom, give us EWI's view on the manufacturing revolution.
Well, the manufacturing revolution, first of all, I have to say it's a very interesting time to be involved in manufacturing technology. I started my career 28 years ago, and I don't think I've had as much fun as excitement as I've had the past couple of years. So the manufacturing revolution is obviously presenting a lot of challenges. I mentioned some of those early on, but it's also presenting a lot of opportunities. And I think for folks like myself and others that work in companies like EWI to develop new technology for manufacturing, we see just an endless number of opportunities for us to bring new tools to the table. The challenge is figuring out which ones to focus on and how you get them deployed. It's always a challenge to get new technology deployed to industry, but the challenges industry face that we need to work on. We talked a little bit about the materials revolution, the new challenges that impact everything on processing and material flow and so forth. There's other challenges, just the speed at which manufacturing has to be done is increasing. So the design to product cycle, as they say, is increasing ever faster. And that's requiring really a whole new approach to how you do things. So we need more advanced software tools, for example, to assist on the design side and do predictive modeling and assess material properties and sort of do your qualification work in a more virtual world, I think, than sort of the traditional empirical approach that we've taken in the past. That's a difficult step for a lot of companies to take, particularly for the smaller players, the smaller, medium-sized players. Having access to those tools is really critical. And so we're working to try and find ways to make some of that more available to smaller players. So for example, almost all of us have smartphones today. We have smart apps on our phones. There is a large wealth of technology, software platforms available for finding element modeling and simulation to assist in the design and predictive side. But for the most part, you have to have expertise to run those. You need specialized hardware on the computer side. You have to know the software and the finite element mesh modeling and so forth. We're moving down a path looking at trying to take advantage of current computer power today and build platforms that really be available on the web, so that an engineer, you still need to be an engineer, a design engineer, but you don't have to be an FEA specialist or know how to build a mesh. You can get access to some of these design tools to maybe design a weld process, design your weld procedure. Design that in a way that minimizes distortion in your part, for example, reducing rework or scrap and that sort of thing. Those are the kinds of things that need to be done. I think it's beholden to organizations like EWI that we kind of step up and help play that role. So the challenges that the manufacturing revolution presents cut across the whole realm from cradle to grave on your product, right? And there's just enormous opportunities, I think, for those of us working in the technology realm to bring new tools to help manufacturers be more successful.
You had mentioned earlier that you have sales offices all over the world, I think you said.
We actually don't have sales offices. We have our main operation in Columbus, Ohio. We have a recently opened center in Buffalo, New York, actually, that's focused on flexible manufacturing automation. We are looking to open other research centers or technology centers elsewhere. We work with companies actually around the world. Most of our client base is in the U.S., but we travel quite a bit around the country and elsewhere, meeting our many clients.
I bet.
Well, I certainly think that you're right about this being an exciting time in manufacturing. The transition from dark, dirty, dangerous to advanced manufacturing, modern manufacturing is in progress.
Yes.
And I don't know where it's going to peak, but for the millennials, the younger population coming into the industry, what an exciting time to be in this.
Yeah, absolutely. The opportunities are endless, and certainly if you're sort of driven to, sort of playing with games and apps and doing software work, there's probably never been a better opportunity to get involved in manufacturing technology. Manufacturing is moving into a very high-tech realm, and in fact, we now see, manufacturing facilities that are as clean as a surgical operating room, and the equipment that sits in there is very, very sophisticated. It takes a great deal of expertise to be able to operate and set up and maintain that equipment. So, I think for any kids today that have some aptitude and interest in science and math and so forth, I think they'll find, if they look, this almost unending series of opportunities to do some exciting work.
Well, it's going to be a long time before you find a clean Ford shop.
That's probably true.
You'd have to go a long way to clean that up.
Well, Tom, we certainly enjoyed having you on the show. I appreciate EWI giving you a chance to come over here and chat with us.
It's been my pleasure.
A lot of exciting things that are happening with EWI. Website, if somebody wants to learn
Yes, you can learn all about us at www.ewi.org. ewi.org.
Okay, great.
Excellent.
Well, we've been talking with Tom McGaughy, who is Director of Technology at EWI, here on Manufacturing Talk Radio at FABTECH 2015, and we'll be probably wandering over to his exhibit a little bit later to learn a little more about it. But that's it for now on Manufacturing Talk Radio.